Welcome, fellow tech enthusiasts. I'm thrilled to introduce you to my brand new YouTube video series, Building the Ultimate Home Lab Server. In this epic journey, we'll embark on a quest to create an unbeatable home server that will transform your digital life. Get ready to unleash your inner geek and become the master of your own tech universe. We'll dive into the world of media servers with MB harnessing its power to manage your vast media collection like never before. We'll also deploy a download command center with the R's legendary apps such as Sonar and Radar, making it ridiculously easy to find and organize all your favorite content from the depths of Usenet. But that's not all. We'll also build a robust cloud platform using Nextcloud All-in-One, give secure and private photo and video backup solution, as well as your very own version of Google Drive. And as we progress through this series, get ready for even more exciting tools to be installed in your home lab. Okay, let's give you a bit of a rundown on the specifications of this motherboard. The A320M-K from Asus. We've got two RAM slots up to 64GB compatibility DDR4. You've got an AM4 socket for Ryzen 1st, 2nd, and 3rd generation CPUs. You've got 4 SATA ports so that you can use this for your SSDs, your hard drives without worry. You've got a host of standard connectors at the bottom, USB 3, and we've even got a PCIe 3.0 16 times port here for your graphics cards, amongst a few other expansion slots, and an M.2 slot to boot. Putting this on its back, you've got the standard old-fashioned PS2 ports there if you want to use legacy devices. You've got a VGA slot, HDMI, and you've got 6 USBs, 4 of which are 3.1 rated. You've also got a gigabit LAN controller, Ethernet port, and your standard audio inputs as well. Now, if you're an avid fan of my social channels, you might have noticed that I recently acquired a Ryzen 9 5950X CPU, which I've actually put into my production home server. This build is going to run with the 5900X CPU, which is a 12-core CPU, 24 threads. It has a base clock of 3.7 GHz and a boost of up to 4.8 GHz. It's got an L2 cache of 6 MB, an L3 cache of 64 MB, and the default TDP here is 105 watts. And that's going to be powering what is going to be nicknamed henceforth the mini mainframe. Which is going to be my new test environment to show you all the great products. We're going to be cooling this thing down with the Artic Freeze 33 CPU cooler, which has 4 copper heat pipes as well, and has it's a large design as well, so it's going to dissipate a lot of heat really quickly. And we're actually going to put this into the system with the back plate. It's going to be mounted onto the motherboard, and we'll do all this before we put it into the system as well, so you get a real close-up view of how this all gets put together. We're going to be using the standard Artic CPU cooling fan that comes with it. We're actually going to be using this in a pull configuration for airflow, not a push that traditionally might otherwise be used. That's unique to the flow of the air in the system. We're also going to be using the Corsair Vengeance LPX 16 gig RAM kit, DDR4, and we're going to have it in 3200 mode as well. So that's going to be nice and snappy because, as you probably are aware, Ryzen CPUs can become more efficient with higher clock megahertz in the RAM. As it's the test environment server, the mini mainframe that we're building here today, we're not going to need a lot of space. So I'm going to be putting in this Western Digital 512GB NVMe with a nice cool copper heatsink that I got off Amazon there, and a nice bit of blue, not paste, but it's kind of a silicon material that dissipates heat into the copper heatsink as well. So 512GB here. A stone's throw away from my main production, which has 65 terabytes, but again, this is just a test environment, and this is the little copper heatsink that I've applied to it as well, which gets rid of the heat from the NVMe really quickly as well. Keeping power requirements nice and low, we're going to be using the Corsair CX550 watts 80 plus bronze certified ATX power supply. It's not modular in any way, shape or form, but since we're not going to be running any SATA connectors anywhere for SSDs and the like, it doesn't really matter about that because cable management's going to be at an all-time minimum anyway. And it's just got the amount that we need. It's got PCIe connectors, it's got the CPU connectors, it's got everything we possibly could need for this build. And again, this is our test production environment anyway. which is going to power a lot of the future videos without me having to mess around with my primary build, my main server. I am going to be throwing in the RTX 3060 gaming graphics card. It's got 12 gigs of VRAM, which is really important because I am going to be running things on this mini mainframe, such as large language models and stable diffusion image generation. Yes, I've got several AMD cards that I could have gone with, but ultimately, time and time again, it's proven more efficient to use the CUDA cores in these RTX cards. And I picked this up nice and cheap in a sale on Amazon. I'll put a link in the description below if anyone's interested in picking this particular model up. It's a WinForce Gigabyte version, so it comes with 3 fans as well, so it's really good. And to round out the specification list, we're going to be using the Aero Cool DS Cube Micro ATX Mini Tower case. I've had this case for quite a long time now. It's proven really useful for a lot of these quick builds that I want to set up. It's got like a really big fan in the front there, and it's got lots of other fan slots around as well. 200mm fan at the front is what I meant to say there. It supports micro and mini ATX and ITX motherboards. It's got 4 expansion slots. You can actually get 2 3.5 inch hard drives in here, and you can also use near the power supply at the back. This is kind of trays for the 2.5 variant as well. It comes with a PSU dust filter. It does have a lot of cable management holes built in, and it's considered to be a toolless drive installation mechanism as well. It has those kind of trays that pull in and out there. A lot of space, but at the same time, not a lot of space, if that makes sense. It's almost the perfect size, really, for this environment that we're building here today to put these components together. So as you can see, it's got quite a few bits and bobs in there as well. Not too bad. It does actually have the ability for water cooling. It has a couple of holes at the back there with those little rubber grommets and stuff as well. And as you can see inside, it does have a slot for a DVD rewriter as well. And that's pretty much the case. It does have a pull away at the top as well, so that's not too bad. And these are those pull-out trays I was telling you about as well. Okay, let's start by putting our RAM in. Nice ASMR style. Clicking those slots in. And they're in dual channel mode. We're going to be putting the back plate on now for the CPU cooler. Just taking these screws out. Is this what this channel wants now? ASMR. Lifting up that motherboard. Poking those holes through. It's all about how we get the motherboard back on the table without popping them out. But we seem to have managed that quite well. Okay, getting back to normal voice mode now. You're going to have to let me know if you enjoyed that or not, because I don't think that is the channel we're looking for. But ultimately, we're going to pop the CPU in now. This is the 5900X AMD Ryzen 9 5000 series processor. And as you can see, I've given this quite a nice cleanup from the server that it came out of, which was my main production server, which is now rocking the 5950X. And what we're doing here is we're looking on the motherboard for the little arrow in the corner, which is right by there, which needs to match up with the arrow on our processor. So if you're at home and you're building this for the first time and you're thinking, how do I get this in? So do not force this thing in. Do not force it in. You're going to need to lift up the latch. There's going to be a little latch, as you can see on the side there. Let me just get these back plate back in properly. That seems good. And then we're going to lift the latch up, as you can see right there. Now, on the CPU, there's going to be also an arrow in the corner, which is right there on the bottom left. And we need to match that up with the arrow on the motherboard. And it should literally drop straight in. You shouldn't force this in. It should just drop down. Once it's dropped down and it's not sticking out, close the latch down, and that's the CPU taken care of. Next up, we're going to be putting the M.2 drive into its slot, but don't forget we're going to need the M.2 drive standoff. If you don't have one of these or you've lost it, you're going to need to go and get one, because otherwise it's not going to be secured in place. There will be little screw slots on the board. What I'm going to do is plug this in just to demonstrate that purpose for you so you can see exactly what it is. So I've put this in without the standoff for a second just to show you basically where that should go. So as you can see, that's exactly where we need to get the standoff put in underneath, because there are a few slots, because you can get different size M.2 slots. So we're going to put the standoff here right on the end. When I know there's 3 different options there, it's a bit finicky to get in, but we're going to try our best. We're going to turn it around on the board. And as you might notice as well, I am using the anti-static wrap on the table. I've been building computers for over 20 years. I've never bought an anti-static strap to use. It doesn't mean I don't advocate their use. I've just never done it myself. And if you look at the motto of this channel, it is amateurs, for amateurs by amateurs. So take from that what you will. Feel free to use anti-static straps, by the way, as you're doing this build. Certainly can't hurt, but I've never, ever encountered a problem myself without them. So we're going to give that a 1/4 inch turn on the board there. Nothing too tight, but just to make sure it's nice and snug. And then we can put our M.2 drive into the slot. And then what we'll do is we'll screw that down. As you can see, a perfect view now of that copper heat plate there with that silicone strap kind of thing underneath it as well. So we're just going to push it up a little bit, make sure it's in nice and tight. Now, I'm actually going to put the CPU cooler together here while we're waiting. And just so you know, there are going to be a few mistakes coming up now in the video, which I'm going to point out to you. And obviously, I did this on purpose, purely to show you and demonstrate what you shouldn't actually do.
Yes, that will do.
So one of the important things that you need to take into consideration when you're aligning your fans, especially when it comes to the CPU fan, is working out the distance of the cable that has got to connect to on the motherboard, and if need be, rotating fans around or moving things around to suit those needs. But you do have to keep in consideration and in mind the overall final design of the product and the placements at which you're going to put them. Now, because I hadn't actually thought this through in this moment in time, what I was actually doing here was putting the fan onto the CPU heatsink. But when I was putting it on the board, you'll notice that the front of the fan, which draws air in, so it's pulling it in towards the heatsink at this moment in time, was facing the I/O ports at the back of the motherboard. Now, in my DS Cube cooling case, the fan is at the front of the motherboard, so I would be creating a kind of conflict of interest where the front of the system was pulling air in, but towards the back of the computer, the CPU heatsink fan would be drawing heat backwards as well. So they'd be kind of meeting in the middle and creating a bit of a pocket of air instead of having a nice flow from the front to the back of the case. And I'll show you that in more depth in a second. The other thing to take into consideration is what thermal paste we're going to be applying to the CPU. I've got Deep Cool, I've got the Mark II thermal Artic paste, and I've got the Mark IV. This is a high-end CPU. It's a Ryzen 9 5900X. So I'm going to go with the Mark IV. It's the latest, it's the greatest, and it should give us the most optimal thermal conductivity for heat in this design. So let's apply that now. Now, when applying CPU thermal paste, you'll have people have all sorts of best recommendations. Maybe you should do an X across the CPU die. Maybe you should do a P-size. I've always gone with just a P-size dollop. I've never done it any other way. And the reason for that is simply because if you're putting a P-size dot right in the middle of the card, and then you're putting down a chunky heatsink on top of that, it's going to naturally spread out in all directions. Which has always given me the best. So if I zoom up here nice and close for you, you can see that my P-size dollop. And, it's always hit and miss whether you get it just right, a bit too much, a bit too little. Go for that P-size, maybe a little bit more, but don't, overdo it. Don't just slap down a ridiculous chunk of paste on here. Because obviously when it does spread out, you do not want this pouring over the sides of the CPU, because we've got that really heavy CPU heatsink that we're going to be screwing down fairly tight, hand tightness, onto the board, onto the CPU itself. So if I give this a little spin for you, hopefully get an idea of what the best typical P-size amount actually is on this. But ultimately, it will come down to trial and error for some of you. give it a go. There's nothing to really lose. If you think you're too much, take it off, take a bit off, scrape it off. But there we go. Now, another little trick that I can teach you here is that when you are putting a heatsink on such as this, and you've got to be really, really careful, when you realize that you have 4 screws to put in and that the screwdriver cannot physically go through a fan, you'll need to take that fan off. And again, this was purely there just so that I could teach you that mistake, and that obviously I didn't do that on purpose.
Yes, that will do.
Now, it's really important that when we're lowering the CPU heatsink onto this CPU with our pea-sized amount of thermal paste, that we get this right, because you don't want to be moving around the CPU heatsink quite a lot after it's been successfully pressed against the paste, because that's when you are going to run into overflow and it's going to be moving it all around. So, as we've done here, we just aim to get this nice and snug and lined up perfectly with the mount plate that we put on the back of the board earlier on. And at this point, we're just going to screw in all the screws. A little technique that you should also note when you're screwing in heat sinks like this is that usually there's about 4 screws. There is in this particular case. And we want to kind of apply equal pressure to each screw as we tighten them. So we're not going to tighten just one all the way and then move on to the next one. We're going to slowly tighten it, just a very fraction of a couple of turns, just to lock it into the back plate, and then move on to the next one. Do the same with that one, screw it in a little bit, and again and again and again until all 4 are in. After that, what we're going to do is the diagonal approach, which is basically to screw in a little bit here, a little bit over there, a little bit here, and eventually, once they all get hand tight, we'll give them 1 fraction quarter turn again, just to make sure it is in nice and tight. In this particular case, by the way, the motherboard's going to be laying flat inside the case versus vertically, as you get occasionally in some cases, which is most of the time. So we don't really have to worry about it having too much weight on it in that area. But yeah, definitely screw them in nice and tight and make sure you're applying equal pressure to all sides. As you can see here, if I go a bit guerrilla warfare style with the camera, there is no thermal paste runoff. It's snug as a bug in a rug. That's a beautiful application, tightened down really well, and I'm very happy with that. Now, as I mentioned earlier on, this is what not to do. You can see that the I/O ports, the input-output ports on the back of the motherboard, where you stick your USBs and your audio jacks and things like that, and LAN cable at the back, is the same direction here as where I'm putting this fan. Now, when this is inside the case, that means that the air that should be going the opposite direction is now coming back in this way. So it's going to pull air from the back of the computer through to the front, but also the fan at the front of the computer is going to be hitting at the back of here. And we don't want that. So this is something that you should definitely not do. Now, I am going to get to putting that fan the right way around in a second, but before I do that, because obviously why not? Why wouldn't I put the GPU in first? So this is the RTX 3060 that I mentioned earlier on. Really good card, 12GB VRAM, which is more than enough for my needs. And I've got the exact same GPU in the main server as well. And they're really, really cool. Really good servers. Really good graphics cards. Which is great. So let's get this slotted in and put down here. Now, there's one thing to caveat to watch out for when you're putting these on before you put them in the case. And that is that at the end where the little sticky outputs are and inputs for the display port, HDMI port, things like that, well, where the PCI connector at the end is, it kind of drops down and it's a little bit longer than the motherboard is on the desk here. So just be wary about that on the desk, because obviously you'll have your motherboard half sticking up and you want to make sure it all is snug in there. So we'll place that down now, and that'll go straight on top of the M.2 drive there. And as you can see, I'm starting to learn very quickly that there is a bit of a drop at the end there where it's not quite sitting down correctly because of that PCI connector at the end, the faceplate almost. So what I'm going to do is I'm going to drag this over to the end of the desk and make sure I get that in there. As you can see right there, you can now see what I'm on about. It drops below the motherboard at the end. So you do have to be careful about that, because otherwise you can have it sticking up in the air and you want it to be set nice and firm. So I drop it at the end of the desk there, and that's a little bit better and easier to maneuver. And this is the moment that I realize my mistake, which is that the fan is pointing towards the back of the board and it's going to draw air in from that direction. So essentially drawing air in from the reverse. Now, unknown to you at this time, there's going to be a fan on the back of the case sat opposite this, fighting in the other direction to pull air out. And we can't have that. So we need to try and keep it consistent, the airflow in the case, and I want the air to run from the front of the machine all the way through the heatsink in the CPU, and then out the back as an exhaust, and then that just makes airflow a lot more positive. So at first, the idea is going to be take the fan off and just plonk it on the other side facing the correct direction. But then I realize that the width of the fan and the position of the restraints on this side don't quite match up on the other side, and they don't quite fit. And this puts me in a bit of an odd position. Usually I have my fans in a pull configuration, so that normally it would sit on the side of the heatsink where the fan would pull the air in and then kind of exhaust it back out over the heatsink, and then it takes it out of the exhaust of the PC fan. That's not going to work for me here because of the constraints in how thick the fan is and the thickness of the heatsink relative to the positions of where the restraints are on the clips to lock this in. So the only actual way I could do this without taking the whole thing apart again, and bearing in mind I've already pasted this at this point, is actually go for a pull configuration. So I'm going to seat the fan back on the other side, but instead of fighting for airflow, I'm just going to flip the fan around and have it pull air from the rear of the heatsink, but coming straight through it. So the airflow is still in the correct direction. And of course, this will make a lot more sense a little bit later when you can actually see this in the case. But essentially what's happening, if you look at the bottom of the motherboard there, that's the reverse of the motherboard, the end, the rear. So when this is in the cube case, the air will come from the other side of this motherboard, from your perspective. It'll pull the air in on the 200mm fan. It'll come across the heatsink because it'll now be pulling air through the heatsink. And then it'll vent it out the rear of the case. And I'll show you that to you in a bit. Just before we put the motherboard in, we're going to put the I/O plate into the back of the case. So make sure you do this now, because it's going to be very awkward and impossible to do it afterwards. So just seat that in there, make sure it is in the correct orientation, and ready to go. Now at this point, I'm ready to seat the motherboard in the case. And that's what I'm going to do now. So let's just get this motherboard seated, and then we'll screw down onto the standoffs to secure the motherboard. And as you can see, if you take note, at the back of the case, you'll see that exhaust fan. And you're about to witness kind of exactly why we had to change the configuration and direction of the fan from where I already had it set up. Now, it's always good to do one final inspection to make sure that everything is lined up and perfect before we start locking this down and securing it in place on the standoffs. So important for me is to make sure that that graphics card is seated correctly. The cool thing about this particular case is that you don't actually need to use screws for the PCIe to lock those in. You can actually use a clamp. But yeah, definitely do some alignment checking. Once you are happy with the alignment of everything and you're ready to lock this down by screwing the screws from the motherboard through into the standoffs, you may proceed to do so. Just make sure that you're using the right size screws for your standoffs. A lot of them are standardized, but occasionally I've come across some that aren't. Usually they come with the motherboard. If you find that you don't have the right standoffs, or you're missing some screws, I can actually highly recommend this particular kit of screws on Amazon, and I'll leave a link in the description for you as well. If you purchase through my link, it actually costs nothing more than you would have by finding it yourself, but it actually does support my channel. I earn a little bit of commission off you doing that, so I'd appreciate that if you're in the market for some screws. That'd certainly help me out. We can now put the power supply into the unit. Make sure, obviously, that the exhaust fan on the PCU is facing the fan filter at the bottom of the case. Most cases have those. We'll slot these cables through all the way to the other side and then seat that in there. When we are tightening these screws on the back of the power supply there through the case, don't tighten them all the way. Make sure that they're a little bit loose until you've got all of the screws secured. Because occasionally you can kind of pull the power supply out a little of alignment a little bit, and then you have a bit of trouble getting the rest of the screws in. So just make sure that that's done lightly. Once that task's completed, we can now actually start threading through some of the essential power cables to the motherboard. So I'm going to start with the 24-pin power connector. Just going to make sure the clip's on the right side, because there's a little bit of a clip on there that aligns up with the motherboard itself. And then I'll just make sure that that's nice and tight. Probably could have done with another standoff at the end of the motherboard here, but I didn't. And that's gone in. The next one is going to be the CPU power cable. We'll slot that through there. Make sure again we're lining up the clips. And you'll see CPU conveniently written on the cable there, so that's how I know that goes there. Pop that in. And just be wary of where your cabling is, especially in relation to your fans. Because I didn't realize at this moment in time, but there was a cable from the rear fan of the case stuck inside my CPU fan, which was attached to the heatsink. This is the PCIe for the graphics card power. And because we're not actually using any keep saying NVMEs, because we're not using any SSDs or hard drives, we don't actually have to run cables all around for those, because I'm using just the M.2 in this test environment. So I'll put that in there and get that up over, and then I'll quickly just align those connections and put them around the back there. The only other real thing that I need to hook up here is the front 200mm fan. It has a fan header on it as well, but I didn't want to put this on the main board and instead opted to just use the Molex connector with the power supply. So I'm just going to connect the front 200mm fan up with the Molex here instead of a fan header, if I get these around the right way. And then that will power the 200mm fan at the very front of the case here, sucking in a nice bit of airflow. The only other thing to do at this point is just connect the power connector up to the graphics card, which is the PCIe cable. It's an 8-pin for this RTX 3060 model, so I'm just making sure that this fitting snug together, and then we'll get that in there. The next step is the tedious task of putting all the wires from the case and attaching them to the motherboard. So a lot of these wires are for the USB headers and the power switches. So we'll do that now. We'll start off. Don't forget to check your user manual, because this is obviously for the A320M-K. The question that I get asked quite a lot when it comes to building computers is, how do I connect the power switches from the main case to the motherboard? And in all fairness, it's not as standardized as it should be. Not all motherboards have the names printed on the pins to show where they go, and not all user manuals have them. I couldn't find this in the Asus user manual. It was very vague. It just said this is number 7 on the map of the motherboard. This is the function panel, and you kind of had to just look yourself. But I'll show you on this particular board how we do that now. So if you look on the bottom of the pins there, you'll see that it's got a diagram of what the buttons are supposed to be and where to put them. And then there's 2 rows of pins. At the top left, you'll see the power positive and power negative LEDs. This is for the little the light on top of this case to show that it is powered on and turning on. So if we pop the relative pins on that, and obviously make sure the text of the connectors are facing you. So as we put that down, you'll see I've got those there, positive and negative, as it's stated. The power switch is next to that, and it's got power button on the motherboard itself. But as you can see there, we'll pop the hard drive LEDs in. Just so you know, that arrow denotes positive. So if you don't know which side's positive, which side's negative, the positive side has always got the little arrow on the back of it. So we'll pop that on there at the end. And then we'll finish off by putting the reset switch next to that. And then there's just a loose pin, a spare pin available there. I'm not entirely sure what that's for. But that's how you put those pins in. At this point, we're basically ready to plug in the main power supply and test to see if this thing boots up. Make sure that the power supply is turned off on the power supply unit itself. There is a switch, just to make sure that there's no sparks or jump of electricity going through here. You don't want to ruin all your hard work just by letting this thing just go pop and prep it like that. At this point, I'm also ready to hook up the mouse and keyboard and my Ethernet connection. Just getting ready to see if this will boot. So, moment of truth here. Let's see if this posts. And if I got the connectors correctly put together on the board. And boom, what an amazing sight. So it's got a new CPU installed. So it's also showing a CPU fan error there, which I happen to know is due to the sensor being faulty on this particular motherboard for me. But the BIOS has booted beautifully and everything is coming up lovely. I cannot argue with that. I'm really happy with that outcome. So after we've done all our build, we can see at least the system posts. But there are a few things that we do need to change in here. Okay, so the first thing that we're going to want to do here is actually get the update file for the Asus motherboard that we have. Because if you're starting from scratch, it makes total sense to get the most latest, greatest BIOS available before we've even installed the main system. So if we do Asus A320MK motherboard, and then we'll go to Asus's website, we'll click on support, go down to driver and tools, go to BIOS and firmware, and we actually are going to be using BIOS and firmware. There you go. And then basically the latest greatest one came out on the 3rd of April 2024, and that is the Asus Prime A320MK BIOS 6223. That is what we're going to be updating to make this the latest and greatest version. So all we've got to do with this basically is hit the download button. It's going to ask where we want to download this to. I've already done this by here, by the way, as you can see. It comes down as a zip file. I've then extracted that zip file. The zip file here. I do run the BIOS renamer. We're going to want to do that as well. And then it renames the BIOS file it downloaded to a compatible extension. And I don't know if there's anything else, but it certainly renames the file to PRA320MKCap. And then all you've got to do basically is copy this file to the root of any USB stick that you have free. Just be cautious because I do have a Ventoy USB with multiple ISOs on it. That does have 2 partitions and it wouldn't see it. So you need to put this onto a USB stick with just one single root partition. So you copy this over onto your USB stick and then you plop that USB stick into your computer and then do Control-Alt-Delete if you're on the BIOS screen to reset it. And then we'll get into that now. So at this point, what I'm going to do is take the downloaded BIOS file that's now on the USB stick. I've restarted the computer. I'm going to go into Tools. I'm going to go to the Flash system. That's my USB stick there, which I'm going to click on just to make sure I can see all the root files. Just going to click on the BIOS file that we downloaded. Yes, I know I'm going to be overwriting the BIOS. Yes, I want to flash it. Proceed. Go into 6223, and then this begins the flashing process, which usually takes no more than about a minute or two. Now that flashed successfully, which is great. What I'm going to do now is click OK. That just resets the system again. Again, we're still going to get those messages with the CPU fan sensor error and the fact that we are running a new CPU there. So we're going to enter the BIOS so we can change a few settings to get this up and operational. Okay, there are a few settings we want to get in here. So we've gone to advanced and we're going to wait and go over to advanced again now. We're in the advanced menu. Trusted computing, no. AMD, we'll leave that and we'll leave the array. CPU, right, this is important. SVM, we want to enable SVM because that is enabling virtualization for the processor. We're going to be using Docker, virtual machines, things like that, possibly in the future. So let's get that on now. Get back out of here. SATA, don't have any of those on you. Onboard devices. Amp, right. On the amp, we want to restore power if there is a power loss state. So we're going to have that as power on. That just means that if power gets lost and then restored, it automatically turns the computer back on. We are using this as a server, so it makes sense to put that in that setting. We also want PC on, power on by PCIe, because we're going to be sending magic packets to this to turn the system on if it's turned off while on the network. So we'll have that as well. PCI subprocessing, SR-IOV support, we're going to want to put that on here as well. This basically allows us to do PCIe pass-through, so certain things like Docker, or maybe if you're running Proxmox, things like that, you want to have this enabled so that you can allow the pass-through and control of PCIe to other parts of the system, really. It also plays a somewhat specific role in multiple networks and virtual machines as well. It could actually help with that due to its PCIe control, but it also works for some parts of the network as well, segregated networks and things like that. We're not going to put the network stack on here. We don't need that. Don't need any smart information at this time. Don't need to configure anything like that. AMD CBS. IOMMU, we are going to enable this. We're not going to leave this as auto simply because several projects that might come up in the future might require that. Essentially, it allows you to share memory space, and it just generally helps with virtualization, containerization, things like that. It just makes things a lot easier to use and more compatible without performance loss. I think that's about it in this area. So the other thing I want to do here is actually turn off the sensor for the CPU fan, which I'm going to need to do because there is a bit of a issue with the sensor itself where it's not being detected correctly on post. That's the only issue. It's not going to impact reading the fan speed or anything like that. It just needs to be taken off for that reason, that's all. Oh, I also need to make sure that we're setting the RAM speed correctly. This is 3200 megahertz compatible RAM. So if I just jump in here to the, is it in here? There it is, memory frequency 3200 megahertz, because that's what this RAM kit is capable of performing at. So we make sure we set that correctly as well. And then we'll save this, and this just gives us an overview of what we're doing. Memory frequency, 3200, SVM mode is now enabled, restore power loss, power on by PCIe, SR-IOV support, and IOMMU support. So that's all turned on and looking good. And just rebooting the system. Oh, right, yeah, the CPU fan error. I literally just said it. F1 to run setup. We just need to ignore the sensor. So if we just jump into the setup. Quickly jump over to advanced. Monitors, CPU fan, and set to ignore. That just means that the malfunctioning sensor there doesn't impact startup. Okay, so one of the ways that we're going to download and install Ubuntu Server onto our mini mainframe is to use a tool called Ventoy, which is like a Swiss Army knife, basically. You can have multiple ISOs downloaded onto the USB stick. And yeah, so if we do Ventoy. We'll go for the Windows zip. Just the Windows zip. That's what we want. Track files here. And here we go. And if we do Ventoy to disk. Okay, it can see the 16 gig USB stick that we have plugged in. So we'll do install, yes, format it, yes. Great, so that's been installed, and we can now see that Ventoy on the device is the same one as the package. That's absolutely fine. Down, if we go to PC, and we'll see that Ventoy is the 16 gigabyte version right here. So if I open that in a new tab, which is great. And essentially, all we've got to do is drop ISO files right into this partition here. Ubuntu Server. Obviously, you can install whatever operating system you want. If you're going to be following along with this tutorial, then we're going to be installing Ubuntu Server. 2404. All links will be in the description below. And that'll start downloading. We're going to download this directly to the Ventoy drive. And the cool thing about this is you can literally have as many ISOs from different distributions as you want. I'm actually going to use my main Lexa USB for this, which what I'm going to do here is go now and switch my USB 6 around. Because what I want to do is pop in this, my Lexa, which is a really good USB stick. It can do up to 150 megabytes per second transfer speed, so it's really quick. And I've also got Ventoy installed on here, which have my Ubuntu installation. I'll show you now. And on this I've got loads of different ISOs, but I just wanted to show you the install process for this. Okay, and that looks almost done. So we can go ahead and install that now by putting this in the back of the mini mainframe computer that we've built and going from there. Okay, let's install Ubuntu Server using the Ventoy. As you can see, these are all the ISOs that I've put onto this USB stick. We're looking for the Ubuntu 24. There we go. And this is the server version, so it's not going to have a GUI or anything like that. Yeah, we're going to try our install. And then we're just going to go through the setup. So we're going to do English UK. Yes. And obviously you set up this how you want to. We're going to do Ubuntu Server minimized. So the absolute least amount of services pre-installed. So tab down and spacebar to select, and then tab down to done. Okay, it's pulled an IP address. Now I can take control most of this and reserve it myself from my Firewall of Gold SE. If your router supports reserved IPs, you should do that after setting this part up. No proxy address. It's just testing the mirrors to make sure they're working okay, so there's no blocks there on the network. Yeah, that's fine. And we're going to use the entire disk, the 512 gigabyte NVMe. And that all looks good, so we'll go ahead with that. Yes, I'm sure I want to completely destroy all the partitions on this drive. And then we'll set up the basics. Now, I would seriously recommend that you set this up with really strong credentials. I'm just going to put some test data in here, because this is going to be, as part of this mini-series, just my test environment. And we're going to not install Ubuntu Pro. Yes, we're going to install the OpenSSH server. We will do this password based for now, but we will switch that up later on. So we'll go for that. And the only thing I really want to install here is Docker. That's the only thing I want to automatically install at this point. So scroll down, select it, and then done. The system will then configure what we've asked it to do and then ask us to reboot the machine. So this is the first boot after configuring, and it'll run through all the boot sequence. And the first time this booted up took a few minutes and kind of got stuck on the network initialization part. But I think that was all worked out with the router on its own. Nothing really changed there, but you might need to give it a few minutes just to run through that boot sequence. So now the system is installed and operational, what we really want to do here is SSH into it so that we can start running our commands. Now, my laptop is running Windows 11 Professional, so I've got PowerShell open here. But whether you've got PowerShell or Command Prompt open, as long as you have the SSH client installed, you should be good to go. To figure that out, you can just literally go SSH. In my case, the username is going to be kltech, and that's going to be at 192.168.6.24, I believe. Let's see if it's booted up and ready to go. Looks good. Put the password in, and we're in. We are now connected to the mini mainframe, which is really cool. And if I do the htop command, that's not installed. And of course it's not installed because we chose the most minimalistic installation possible. So there's probably almost nothing installed on this whatsoever. So that's really what we're going to do. But now we've connected to that and we're happy with that, I'm just going to install the htop command. The first thing we should do on this installation is as follows. It should be sudo apt update -yes. And then we're also going to do sudo apt upgrade -yes. That gets us the latest and greatest repositories and lists of applications that we can install and download. So that's great. And then all we need to do at this point is do sudo apt install htop. And htop is the equivalent of Windows Task Manager. So that's installed now. So if we look at htop, this shows us all the running processes on the system. If we do Shift and H, and by hitting Shift and H, you can actually focus the processes to user running threads versus the entire system. So you can like kind of localize it to what you've got running versus what's running all over the place. Looking good. Everything's up and running. The Ryzen 9 5900X CPU, as you can see, all its beautiful cores. Memory usage is less than 500 megabytes of RAM. And we're not even touching the swap space either, out of the 16 gigs of RAM that we have on the system. So that's it. That's episode 1 concluded. From Ashes to Olympus. Episode 1 is done. In the preceding episodes of this mini-series, which should be out at least weekly, we will explore installing things onto our mini mainframe, our home lab. Things like Nextcloud and Image and the RZAPs, Zab, Usenet, anything and everything onto this. But I wanted to get this out because I had a few requests for building a computer, and I know a lot of YouTube channels have a lot of cool little mini PC designs and this, and not everyone's going to have Ryzen 9s lying around, but I happen to, since I was upgrading. They're just components that I had spare while I was upgrading my main server, so I thought, why not? 2 birds, 1 stone, and just use it. and just see what we can do with it. And this is a brand new test environment for me, which is a great asset on this channel, because now I'll be able to do all the cool little things that everyone wants me to do without kind of messing up my main server that I use for production use case. So yeah, I'm looking forward to getting some reverse proxies on here, showing you the ins and outs of everything. And as always, thanks for watching, and I'll catch you in the next episode of the Ultimate Home Lab.